if we could see for dimensions, what phenomenon will you see? This video is used in a visual manner, introduce you to the concept of four-dimensional space. First, let's look at the image on the screen. What your brain might see or understand is 6 triangles are arranged to form a hexagon. Or, you might also interpret it as a hexagon, and the 6 outer vertices are connected to the center vertex. And both of those are true. But now things have changed. Your brain may be thinking right now, there are no hexagons. It's actually a cube. Although you are still looking at the flat screen, but your mind has moved from a two-dimensional model, switched to 3D mode. You understand that certain edges must cross on the screen to represent the shape of the cube. Although these intersections appear to overlap, but you also know the edges of the cube don't actually coincide. The two-dimensional way we see the world, it's very different from the three-dimensional approach. Then humans can understand the mind, or a higher dimensional world, in order to better understand this topic. So let's start with a few basic concepts. Topping is a branch of mathematics. The research is geometry, properties that remain unchanged under continuous deformation. For example, the number of holes in a donut. No matter how we stretch, knead or bend the donut, he still has a hole. It is this nature that Tuopu is concerned with, even if the shape of the object changes, as long as it doesn't break or reconnect. The extended nature of the object remains the same. Pop is a mathematical object that can exist in any unique form. And the simple answer is this: popularity is a local geometry that looks like Euclid space. For example, 1 is popular for including straight lines and circles. 2 for popular including open surfaces, like a flat disk, ring belts and closed surfaces such as spherical and torus. 3D trends include spheres. For example, a solid ball, solid torus, common donut shapes and tetrahedrons, etc. Boundaries in topology. Boundary refers to the edge of a surface or form. For example, the boundary of this plane is the 4 sides that surround it. The annular belt is bounded by 2 concentric circles. They define the contours of the shape. When applying extension transformation, no new boundaries will be removed or added. On the other hand, a sphere or torus has no boundary because they are closed surfaces. Here we go. Let's consider an open two-dimensional epidemic. You can easily tell. Fashion has 2 sides. One is on top, one is below. If an ant is on the top side, he has to cross the border to reach the lower side. Here's an interesting puzzle. Can you think of one that only is a two-dimensional dough popular? That is to say, an ant on top. You can go directly below without crossing the border. Is that possible? If you want to think about it, pause the video and think carefully. A way to solve this puzzle is to make a bag and put one end of it, connect with the other end on the opposite side. But before connecting, we're going to twist the bag 1.5 first, then combine the 2 ends together. The resulting surface, the famous Mobius belt. Why does he only have one face? We can do this by making a simple observation. To prove it, imagine an ant crawling on one side of the Mobius strip. He will eventually go back to square one. It's actually the other side. In other words, the upper and lower sides of the Mobius strip, it's actually the same side. If you zoom in, you can see the sides of the Mobius strip. Boundary. It seems to run parallel to the length of the bag. And we know that parallel lines never meet. But if we look closely, we'll find the Mobius strip has only one continuous boundary. Does that confuse you? One of the most attractive features of the Mobius belt is that if you cut it in half, he is not as we usually expect. split into two parts. We generally believe that cut anything, we'll get to separate parts. But when you try to cut the Mobius strip, you'll find that he doesn't split. Why is that? Here's why. The Mobius strip has only one consecutive edit. When you cut in the middle, the incision did not touch the boundary of the bag, so the bag is not separated into two parts. You can also do it in another intuitive way. To understand this phenomenon, first cut the bag in half. Then bend the bag so the two ends meet. Then give him another twist and a half. Finally, connect the two ends. You will find he still maintains a continuous structure. If you take Mobius with the case width, cut into thirds, it gets stranger. When you cut, you will find the incision went around Mobius twice to finally form a closed ring. When you separate these parts, the resulting shape will surprise you. This process can be done by cutting the bag first, and then we do a semi-twist. Finally, connect the edges to understand, so you can visualize it better. This miraculous phenomenon, here we go! We're going to look at it from a different angle, thinking about a classic time travel theory, grandfather apostasy. Grandfather apostasy, usually used to refute the possibility of time travel. His basic idea was, if you go back in time and kill your grandfather, then your mother wouldn't have been born. See you. You couldn't have been born. Therefore, you can't go back in time and kill your grandfather. This is obviously a paradox, because he shows a logical contradiction. Some people think that this logical inconsistency means time travel is impossible. However, there is an ingenious solution, and this is through the Mobius strip. To explain this argument, suppose we put the timeline. It's on the surface of the Mobius strip. In 2021, let's say you have some reason, acquired a time machine, decided to go back in time to kill your young grandfather, although you don't know why you do it. By this means, your time travel is mapped to the Mobius strip and the wonderful structure of this bag, and it provided a way of settling arguments. Now you're back in 1940 and killed your grandfather. If your grandfather had died as a child in 1940, so the mother couldn't have been born in 1970, and you won't be born in 2000 years. So in 2021, there is no existence where you can go back in time, but things are different now. Let's skip the discussion point briefly. Let's see what happens next. If you don't have it in the first place, go back in time. Then no one could do it in 1940. Kill your grandfather, so grandfather will live. Born your mother in 1970, and your mother could give birth to you in 2000 years. In 2021, you will use the time machine again. Go back in time and kill your grandfather. And the cycle goes on forever. Now we see, the entire surface of the Mobius strip is covered. Use. One of the neat things about the Mobius strip is that, like your mother was born and your mother. Dear, there is no such opposing event as birth. Exactly located on the opposite side of the Mobius strip. In 2000 years, you were both born and not born at the same time. In 2021, you go back in time and you don't go back in time at the same time. In 1940, you kill and don't kill your grandfather at the same time. Each event and its opposite are both in the bag at the same time, occurs in length. This looks more like an apocryphal theory, rather than the theory he was trying to solve. However, when you think, restricted to the surface, when these recurring events occur, the logic behind causality, it seems to blend together smoothly. It becomes a causal loop. Let's discuss. Elevate to a higher level. Consider a sphere. Like holding. Sphere is also a two-dimensional popular, but it's a closed surface because it has no boundaries. In addition, we can also think of a sphere as having two faces. One is outside, the other is internal. unless we cut it open. Otherwise, you can't see the inside. Here's a new puzzle. Can you think of a closed surface into D? Is it popular? Ants go from the outside to the inside without having to cross the border of popularity. Is that possible? If you want to think about it, you can pause the video. This popular to D screen is called the Klein screen. It's a closed surface with no boundaries. If an ant walking along the surface of Klein Ping, he will be able to go outside without hitting a border or falling off an edge. Here's why. Although Klein Ping is a closed surface, its outside and inside are actually the same face. Note that Klein Ping is in some places. It seems to intersect with itself, but that's just a visual limitation of 3D space. Give an analogy. When the video starts, we see a three-dimensional cube. We understand certain points must intersect on the screen to represent the cube, although these focuses seem to intersect. But the edges of the cube are not actually staggered. We can put this idea applied to the Klein screen. Also remember, you're looking at Klein to the image of the bottle, and he can actually only fit into 4 dimensions. Explain the 4th dimension. It's like people who are born blind are described as having the same color. We can't visualize him accurately, but we can try to understand. So far, we're talking about spatial dimensions and the dimensions related to space. However, there is another dimension that we share. So understandable. That is the time dimension and time. Imagine a sentence that means a line segment named ZL. He was trying to understand 2 dimensions. How can L distinguish a disk and a triangle? One way is to make these 2-dimensional shapes slowly cross the plane of linear existence of small l. When the disk crosses this line, little l will initially see a point. This point gradually gets longer until it stops. Then it shortens and disappears. For the triangle, little l will see him suddenly become a long line. Then it shortens until it disappears. We're actually taking these 2-dimensional shapes, cut into line segments that small l can understand one by one. Since ZL can only understand 1 spatial dimension, he needs the passage of time to make up for his lack of understanding of the 2nd dimension. In other words, little l is through time instead of space to understand the 2nd dimension. Now imagine a 2-dimensional square. Squirrel. He was trying to understand 3 dimensions of space. How does he distinguish a sphere and a tetrahedron? The squirrel's understanding is similar to that of ZL. When the sphere crosses his plane, the first thing he saw was a dot. Then it becomes a gradually increasing disk, and then it gets smaller and then it disappears. And when the tetrahedron passes through, the squirrel will see him suddenly transform into a triangle. Then it shrinks and disappears. Same as before. We take these 3-dimensional objects, cut into flat to D shapes. Let squirrels understand 1 slice at a time. Back to the Mobius strip. He is a 2-dimensional pop, but only in at least 3 dimensions. If we confine it to 2 dimensions and squash it, leaving only his boundaries, you can see it clearly. That's where the curve intersects itself. But if we take a part of him, mention 3 dimensions, he stopped giving himself up. It seems to add an extra dimension. You can get rid of self-inbreeding. When the squirrel approaches, he could see the boundaries of the Mobius strip. For him, seemingly intersecting points, actually at different points in time, points occupying different positions, so the squirrel can understand. Even though the Mobius bands intersect in this 2-dimensional representation, curves in 3-dimensional space do not cross themselves. And finally, we are ready to enjoy the full picture of the Klein bottle. It's like a Mobius strip. The Klein bottle is a 2-dimensional pop, but it can only exist in at least 4 dimensions. What you see now, it's just a 3-dimensional representation of him. As we just said, by taking part of the Klein bottle, you talk about 4-dimensional space. We can get rid of his inbred behavior. To visualize the 4th dimension, we pass through time. Cut the Klein bottle into 3-dimensional slices. Observe bit by bit.